We start from a clean machine. Here we are installing the essential tools: Git, Docker, kubectl for Kubernetes, and Python pip, all in a single apt command. And we also need the Google Cloud CLI to interact with our GCP project. I'm not running these commands because I already have them installed in my local machine. So after everything is done and installed, try running gcloud -version. If your output is something like this, then you can you can confirm that the installation is successful. Now we'll clone our GitHub repository, that is IE7374 MLOps Adaptive ML Interface. This project is an intelligent multi-model orchestration platform that uses reinforcement learning agent to dynamically route routes between frames. So I'm currently cloning this repository into a demo repo which I've created, and we can verify that the demo repo has successfully cloned the repository. After cloning that, now we authenticate to Google Cloud Platform using gcloud authenticate login. Here you can see I'm logging into my Google Cloud account, and once authenticated, we set our project to Adaptive ML Interface, the GCP project where our Kubernetes cluster is running. To set that, we use gcloud config set project adaptive ML inference. Once we update that property, now we fetch the credentials for our GKE cluster, Adaptive Interface Cluster, located in Europe West 1B. This configures kubectl to point at our production cluster on Google Kubernetes engine. So now you can see we have successfully fetched the cluster. You can also verify with kubectl get nodes. Now this is a GitHub action pipeline where we push code to main. The full pipeline triggers automatically. The CI test passed. And also coming to the RL Docker build and push, the image built and pushed to GHCR and deployed to GKE. Once the RL Docker build and push successfully runs, it triggers the deploy to GKE, where automatically deployed after Docker build. When we push code to main, GitHub Actions automatically trigger the full build and deploy pipeline. No manual steps are needed. Now we can also verify all resources are running using kubectl get deployments -n adaptive interface. Inference. It's a small typo. You can see everything is running. And you can also get the ports kubectl, get ports, -n, adaptive inference. You can see all the running ports and completed ports over there, and also their age. And also we can see the services. For that we can also use kubectl, get services, -n, adaptive inference. Back in terminal, kubectl confirms our cluster is healthy, one node ready at GKE, all 5 deployments are up to date and available. Backend, Grafana, MLOps and Prometheus and the UI, all pods are running. Services are exposed correctly and the UI service is a load balancer with a public external IP. And the backend health check returns the status ready with engine ready true. Now we'll try going to our ML adaptive interface, which using a public IP. So here you can see the ML adaptive interface live dashboard. The Streamlit dashboard is live. The both RL agent and YOLO models are loaded. The UI supports 2 input modes, that is the live camera and a video upload. Here we are uploading a 4K city drive video to demonstrate the inference pipeline. The system processes each frame through 2 parallel paths. Path A uses the PPORL agent to dynamically select the optimal YOLO model, and path B uses small v8 small or a selected model of your choice as a fixed baseline for comparison. Note the production GKE deployment runs CPU ONNX interface optimized for cost efficiency. And we also have a live camera option. The dashboard is ready and stream if you toggle this switch on. And now for a second we'll look at our dashboards for the metrics. So in Prometheus, we query adaptive interface frames total. Yeah, right in the search bar, if we enter adaptive inference frames total, this counter tracks every frame passed by the backend, labeled by instance and job. The graph shows the metrics being scraped every 15 seconds. Prometheus is collecting latency histograms, model selection counts, WebSocket connections, and throughput, all exposed by the fast API backends. And coming to our other metrics, that is Grafana dashboard. Oh, sorry, I just made a mistake over there. I have to change the port number as well. Now coming to the Grafana dashboards, it shows frames processed in total, active WebSocket connections. The model selection distribution showing what percentage of frames the RL agent routes to nano, small, and large. Adaptive path latency at P50, P95, and P99. The frame throughput in frames per second and latency savings. How much fast the adaptive path is compared to the YOLO V8 small baseline. All panels update in real time as the traffic flows through the system. Prometheus scrapes metrics every 15 seconds. Our Grafana dashboard shows real-time adaptive latency, model selection distribution, and active WebSocket connections. And also we have alert rules fire if P99 latency exceeds 500 ms or the RL agent shows routing imbalance. Every 6 hours, a Kubernetes cron job runs our drift detector. It pulls sessions metrics from MLflow, runs an evidently AI distribution comparison against the reinforcement baseline, and checks performance threshold. If drift or decay is detected, it automatically fires the retrain.yaml GitHub action workflow. You can see all the alerts which are set. Now coming to the retrain.yaml, which is in the GitHub actions, which are triggered automatically when there is any drift detections. Here is the retrain.yaml. This runs DVC to retrain the model, applies a quality gate, builds a new Docker image, and performs a rolling update on GKE. Slack notifications are sent at each stage. To summarize, the entire deployment is fully automated. A git push trigger build and deploy. The model is monitored 24/7 via Prometheus and Grafana. Data drift automatically triggers retraining and redeployment. No manual steps are required after the initial GKE cluster setup.